Just give it 1 second. Yeah. So once again, good morning, everyone. Happy Friday. Thank you for joining. Just a quick disclaimer, this call is being recorded. If you don't want to be recorded, you may want to drop off now. Hugo, floor is yours. Take it away.
Yeah, thank you. So, thank you, Navid. So today we're going to talk about Dapr. So for people who don't know me, I'm Hugo Girard. I'm a cloud solution architect at Microsoft. And again, today we talked about Dapr. That is like the short name for Distributed Application Runtime. This is the agenda today. So I will explain what is Dapr, how to use it. It's made of what basically, how to do local development with Dapr, and when you move your code to Kubernetes, how it works. We show the sidecar pattern. So if you people here do Kubernetes, they kind of use of that. And I will talk about Dapr versus service mesh. Can you use the two together? And obviously a demo to show how to use it. So basically why Dapr was created. As you know, the more we start creating system, the more distributed it is. First, it was the monolith, and now we start breaking that to microservices. And do those kind of microservices architecture can be complex and difficult. Mostly if you move your code, you run it on-prem sometime because some customer have some compliance. After that, you move that to Azure, or you need sometime even to be multi-cloud. So you will need to write a lot of time the same piece of code, let's say to call a service bus that is in Azure versus like Kafka on-prem will be different. So more code, you will have a bigger technical debt. So Dapr help with that. It's like basically a glue. It's really configuration based. So you never need to do any code change. So the advantage of that is you will be able to move your code everywhere without writing any line of code. And on top of that, it's not based on a specific programming language. I mean, you don't need to use strictly .NET or strictly Java. So it's really like language agnostic. It's a framework, it's a runtime. So they have some SDK available, but it's not necessary. You can do everything, with C++, for example. So again, what is Dapr? So at the top, you will have your code can be written in anything, Go, Node.js, Python. You can use SDK or not. And in the middle, you will have what we call building block. So Dapr give you those kind of piece of building block that will give you functionality. So let's say you want to do service to service invocation. Let's say a microservices that call another microservices. You will use that building block. You want to have some state management here, like more key store kind of. Again, you will use this piece of code. And all communication through the Dapr runtime would be done through HTTP or gRPC if you want more performance. So like I said, it's really the glue, to communicate to external system or like external component on-prem or in the cloud. And again, you can move your code anywhere, like on Edge, VM, and any cloud provider using Dapr. So this is like all the building block that we have today available. Obviously, I won't be able to cover all of them because there's a lot. So I will just cover like the four first, like the service to service, the state management, the pub and sub. That is really, when you use like a service bus, like Azure Service Bus, RabbitMQ, Redis, and bindings. Bindings is really to have your code react to any kind of events. So you won't need to write use a SDK. Let's say you use Azure Event Hub and you receive event from it. Then just a configuration file, you're ready to receive events from Azure Event Hub. You want to use Kafka for X reason or your code run on-prem. Again, you don't need to have any knowledge of the Kafka SDK. You change the configuration so your code always stay the same. And for the output, same concept. You want to send event, let's say for the external system, SMTP server, I don't know, Twitter, Twilio. Then again, it's just like a HTTP call, and you don't need to know anything about like the tech behind it. So this is how Dapr kind of work in a nutshell. So in this example, you have a pod, and you will have like two containers running inside the pod. So you will have your services, that is your application here, and you will have another kind of process or container that will run, and basically it will be the Dapr sidecar. So every time you want to do something, in this example, is let's say send a message to a service bus, you will do a call to your Dapr sidecar that at the end of the day is basically a proxy. And this one with like what you configure, like the component that at the end of the day is just a YAML file, will redirect to the goods service bus. So if you run on-prem, you will have a configuration for RabbitMQ, so the message will go into that queue. If you're in Azure, you leverage Azure Service Bus, and the message will go there. And again, you won't need to change any line of code. Here's a little example to the right. In this case, we use a SDK, but everything can be done without it. So you create a Dapr client that basically just a wrapper on top of a REST call. And here you said, hey, publish an event of type order data in my component name pub sub, in the queue name new order, and with the payload. So the Dapr sidecar will know how to redirect on which service bus. So if you're on-prem, RabbitMQ, in the cloud, Azure Service Bus. And this what look like a component. So if you used to do Kubernetes, it's pretty similar. So you will have like the version of the API, the kind in this case is component, the name. So the name is really important because when you use like the SDK, or if you do a REST call, you need to pass the name of the component all the time. Namespace would be used if you're in Kubernetes mostly, the type of the component. So if you use a state storage, it will be state dot, in this case is Redis, the version, and all the metadata. So obviously metadata will change depending on the component you're using. If you go, let's say with Azure Service Bus, you have like those advanced feature like session detection of duplicate message, so you will be able to specify that through like the metadata. So you can have your programmer really focus on the code and delivering value to the enterprise, and have like your cloud operator or sysadmin like just configuring those components so they will know kind of like the tweak that they need to put in the metadata. So programmer write code, and after that the ops like they will just configure like depending where the code is running. So this is an example of service invocation. So how it works is like you start your application and you will have the process that is the Dapr sidecar running. And when you start your Dapr sidecar, you specify, hey, this is the HTTP port that I want you to receive like the traffic, or gRPC. So in this case, you see I have like the port 3500 that I specified to my Dapr sidecar that is attached to the Python application. And the Python app want to communicate to this node application that have like itself like another Dapr sidecar. And the node application have like an endpoint called new order. So normally if you run in Kubernetes, or even if you run on-prem, you will need to know the FQDN of the node application to be able to send the traffic. If you go with Dapr, you don't need that. You just like communicate to your sidecar attached, to the same process, and you say, hey, invoke the application called node app and the method new order. And Dapr will know, okay, I need to call this specific Dapr sidecar, and this one would be able to redirect like to the endpoint of the application. So no need to know, oh, where is this app? What is the address? Just all the communication, all the service discovery would be handled for you. And this is just a quick example again. Like if we go back like the previous example, you can just do like a simple HTTP call. So everything you call like pub/sub, the input I was talking, the path will pretty be similar all the time, just kind of the end that will change. But you can leverage SDK. So again, it's like simpler. So the example at the top, it's like in .NET, and at the bottom in Python. And you can see like it's really similar, like depending which programming language you're using. So when you start developing like locally, how it works, you install a CLI, and you would do a Dapr run with the name of your application and some parameter. So this will start your application, and another process that is your proxy, your sidecar, that is Dapr. And locally, when you install the runtime, that would give you like 3 containers. So you will have the one that's the actor placement. So you can use the actor model in Dapr. So if you go use that, this is the job of the container to would know where to put the actor. After that, Zipkin tracing. So you come with distributed tracing with Zipkin. If you go to the cloud, obviously you can configure other tracing. And by default, you have a pub/sub and a state storage that is Redis. And Kubernetes, almost similar, except that will run inside a pod, but you will have like more component. Like you will have one here that will inject the Dapr sidecar. So, this term when you have an application and you say, I want my application now to be Dapr aware, you say, I'm Daprizing my application. So you would put some metadata and I will show it through the demo. And your Kubernetes manifest file and the runtime injector will just cache, those metadata and will know, oh, this is a Dapr application. So it will spin like the sidecar container for you. The search authority, all communication, through the Dapr sidecar is all MTLS. So that's the job of that. And obviously like an operator just to, manage everything that is Kubernetes and component in Dapr. So
Hi,
yes.
Hugo, sorry to interrupt. Please, and by the way, do you want to take questions at the end or do you want to take questions now?
We can do it now if you want. Yeah, no problem.
Okay. There's a question like, and please feel free to speak up if I don't describe it right. How is Dapr to Dapr communication? Is it over secure channel?
Yeah. So basically it's like through gRPC and everything it's encrypted between the two sidecar.
Uh-huh. Okay.
That's
Thank you.
that's okay. Okay.
Thank you. Yeah.
Yeah. So like without Dapr, basically is what I was saying. Like when you write code, you would probably like in this example, you have an API, you have your repository layer, you would create an interface for your abstraction, and after that, you would create a concrete class for every storage that you will need to implement. So if you go to Azure, in this case, let's say you use Cosmos, then you would create a Cosmos repository. And after that, if you run locally, Redis, and maybe after that, you migrate your code in Kubernetes for one of your customer and this cluster is on-prem, so you will use maybe another storage. So again, another concrete class. So you see, it would just kind of increase, so more code you write, more code you need to maintain. That's obvious. But if you go with Dapr, you don't need to write all those kind of concrete implementation. You will still probably have an interface just to do abstraction in your code and for unit testing, but you will probably just create one concrete implementation that will leverage maybe the SDK or just a HTTP call all the time to your sidecar. And after that, it's just the configuration you will change. So this code basically will never change except if there's a breaking change in the Dapr API, obviously, but you should never touch this code anymore and your code will be portable really easy. You will just change the configuration. And if you one day you don't want to use Cosmos because Azure like release something and you kind of storage that you want to try, again, you change the configuration and you're good to go. This, like I will go fast on that. Basically, is just to explain what is the sidecar pattern. You have your host, you have your application, and another process that is your sidecar that provide functionality like a proxy, some login, or etc. So, if you use service mesh today and Kubernetes, that's the same concept. Like there's a lot of stuff in Kubernetes that implement this pattern. So Dapr is based on that too. A question I got too, like from some customer is like, that's good, but what is the performance consideration? When you use Dapr, like because like it's you will like proxy everything to the sidecar. So yes, for sure you will have like a a small latency, but it's millisecond because again, communication between the two sidecar is on gRPC, so it's pretty fast. So you won't see like a second of degradation. So it will be almost invisible. So it's the same kind of concept, like most of customer today, they have service mesh in Kubernetes. Yes, you have a little hit, but it's really little. And now like another question come often because when you see that's like, okay, it's like Dapr a service mesh. No, Dapr is not a service mesh. And in fact, you can use the two together. There's a good talk about it like on the Dapr YouTube channel. So if you're interested to learn more, I recommend to go there. But in a nutshell, yes, they have some functionality that are similar, but Dapr focus really more about the developer, to provide you those building blocks that you see at the top here to help you writing your code. Let's say you want to do a pub sub, you want to do some event-based coding, a key store. So that's what Dapr will provide. In the service mesh, you focus mostly more like everything that is network traffic, like traffic splitting, maybe testing, routing. But here you can fit in the middle. There's some stuff obviously that they kind of share, like all the MTLS when you kind of do the communication between like service to service, collecting metric, resiliency, and all the distributed tracing. So in a nutshell, if you use the two together, you should deactivate, like those features that are common in Dapr. So Dapr will just focus on the block at the top, because if you activate collecting metric from the service mesh plus Dapr, now for sure you will see some performance be downgrade. So that's one thing to keep in mind. You can use the two together, but if you use the two together, just focus the top for Dapr and deactivate what is common. So that's basically like show like what I just explained, like Dapr really like application concern. So I think this arrow even is confusing. Dapr, his goal is really communicating with the external system, component in Azure, and when you put your service mesh is really for all the networking concern. So now for the demo, the demo is really inspired of something called the Dapr workshop. So if you want to go more hands-on and deep dive in Dapr, there's a workshop on GitHub that is free, so you can do it. And if you go to the official documentation of Microsoft, that's the same workshop that we recommend. So this is kind of the use case. So basically, you're in an highway and you have like a camera. So here, like you enter here, the camera take a screenshot of your car plate, save it in a storage, and you have another camera later, like 10 kilometers later, that again take a screenshot of your car plate, and after that calculate like how fast it took your car to go to point A to point B. If you're too fast, like, oh, you're gonna have a fine. So you will call like a system that have all the information of the registered car. So return like, okay, this car is this person, John Smith, this email address, and John Smith will receive an email with a fine. So that's the use case that we're gonna show today during the demo. So this is all the component and microservices that are in that use case. So you have a camera simulator here that will just be a normal console app, and it will fake like some entry of a car on the highway. And you have like this microservices that is traffic control services and have two endpoints. Like when you take the screenshot, let's say when you enter the entry cam and when you exit the exit cam. From there, this would calculate like how long it took you, to go to point A to point B. If you have a fine, this will put a message in a queue. The fine collection services is listening on the queue, get it. We'll call the vehicle registration services, hey, give me the information. And after that, send a fine by email. So you develop locally, or let's say you were inside like a Kubernetes cluster on-prem, that's the component that will be used. So the camera simulator will send some event to like something called Mosquito, that is MQTT protocol. After that, the traffic services will receive those events through is Dapr Sidecar, save the information of the car plate in Redis. And if you have the person have a fine, send a message in a written queue. The fine collection services will retrieve a message, ask the information to the vehicle registration services, and after that, send a fine by email. And here, like we just spin a simple SMTP server. And same concept in Azure, except it's going to run into AKS. And you see like the three component will change. So in Azure, I will use EventHub because now you want to use PaaS services and maybe not run everything inside your Kubernetes cluster. I will use Cosmos DB for the storage and Service Bus to replace RabbitMQ. At the bottom, though, like the SMTP server will stay the same. It will just be a Docker container inside my Kubernetes cluster. So let me go to the demo. So like I said, everything is really component based. So just show you a little bit the component. So this is the one locally. So like I said, entry cam is just like a MQTT protocol, and you just give a name to the component. And the code related to that, basically there's just a normal REST API with two routes, like entry cam and exit cam. So you just need kind of a route with the name that you put here. And the Dapr sidecar will know like, okay, when I receive a event from MQTT, I call the endpoint entry cam. And the same for exit cam, like when the car was exiting the zone of control, same thing, an event is sent there, and it will look for the endpoint exit cam in the code that is here. So you see, like the code is not even aware that you will receive like an event from an event system. So for the code, it's just like, hey, I'm a REST API. That's it. And here, like when you publish to the queue, we use the Dapr client SDK, but you see here, like I have the endpoint. So again, what's the name of the component? What's the name of the queue and the payload? So it's really easy, like to switch your queue. Like here, like I use RabbitMQ, and when I go to Azure, I use a service bus. But no code change. It's transparent. It's really configuration driven. So let me start like the tree application. And how you start Dapr application when you develop locally. Basically, let me show you. Like I said, everything comes with a CLI. So you do a Dapr run. You need to pass a app ID. And this is really important, mostly when you do service-to-service invocation. So you will say like, hey, I want to call this application. So it can be anything. So the port of your application, that is listening to, the HTTP port of your Dapr sidecar, and the gRPC port. So here you can communicate to your Dapr sidecar HTTP or gRPC if you want this extra inch of performance. And where is all your component? So by default, when you install the Azure, the Dapr CLI, you install like some component, but when you do your development, obviously you can create other components. So you just specify where they are here and the command to run your code. Here it's a .NET application, so it's going to be a simple .NET run. If it was like Node, probably an npm start. So let's start the 3 microservices. And Dapr, the good thing too, come with a dashboard that you can use when you run locally or in Kubernetes. So let me just show you the dashboard. So now I'm running locally. So like you see Dapr, see how you have like those 3 Dapr application that I see right now. And you can even like click on it and you see how the application got started and more information. So now let's start the simulator. So the simulator is just a simple console app that when you run locally, send to RabbitMQ, and after that, when you run in the cloud, basically send to Service Bus and Event Hub. So like I said, I was using Mosquito, locally. So now you see, I will have like some vehicle that start to enter and be tracked. So if I go in the traffic control services, now you see like the traffic coming. And after a while, if I'm lucky, I should see a fine passing. Yeah, here you see like we got a speeding violation services. So if I go in the fine collection services, we see like this fake person receive a ticket. And if I show you the mail server, yeah, you see like now like some ticket enter. And maybe one last thing I will show. When you run locally, I didn't configure it for Kubernetes, but here, like if I want to do some, I can see all the trace here with this, so you can see like how many times like the duration of the call, and I can see like the traffic kind of life. So another neat feature. So now let's do the same, but in Kubernetes. So I'm going to stop everything here.
Hugo, just one. There's one question in the chat window about the option for observability, like how you can do like tracing and all that. So
So like I said, by default, they come with Zipkin, like when you develop locally for the distributed tracing. But obviously, you can use other system. There's a bunch on the Dapr documentation. If you're like in Azure, you can be application inside. I think they even have for Prometheus and Grafana. So basically, you will configure what you want to use to do this kind of monitoring and distributed tracing.
Thank you very much.
So let's load that. Yeah, so now let me start everything in Kubernetes. And now if I go again to the dashboard, So when you want to run some specific command in Kubernetes, basically like you pass this parameter. And we just show you the dashboard because when you're in Kubernetes, you give more information. So now, like, again, I see this is all your Dapr application that you have, the number of replica, if the control plane of a Dapr is healthy, you see all your namespace, and by default, when you install Dapr in Kubernetes, like it will install everything into Dapr system. And in my example, I created another namespace called Dapr traffic control. From there, I can see even like all the component that I configure. So that can be nice, like, like you would probably install maybe a different component and different namespace. So you would be able to see, oh, this namespace use this, or dev, maybe you would use something different than production. And if I go back here to my services, I can even see the log. So I will see the log of the Dapr sidecar. So here, like, if you have an error, like sometime when I was doing development, I didn't configure the component correctly. So you will see the error here. But the other cool feature, if you enable the login in your application, like, any kind of login that you use to with Kubernetes, but you see it in the dashboard. So now let's start the simulation, but using Evanov. So like I show in my diagram now, I'm done using Mosquito. I'm using Evanov because I'm in the cloud, so I want to use like PaaS services. So now you see I started like using Evanov, so I start like 3 fake camera. If I go there now, I see again the same that I was seeing locally, but now I'm running inside Kubernetes, leveraging like cloud component. And if I go back to the services, the fine collection services, if I'm lucky, actually, I already have some fine. Yeah, see, I already received some fine. And like I said before, the fine collection services called vehicle registration services to retrieve information of the driver. So let's see even if this one receives some traffic. And it's the case. So here you see like all the communication, and now everything I'm running inside Kubernetes. And the last thing I will show is again like the same mailbox. So basically, the mail server, I could use like a real one, but like for simplicity, I use it again the same that I was developing locally, and I just expose it like with a simple load balancer services. So I'm gonna show it to you. And again, we see the ticket like, and last thing, like just to really prove again. So if I do, so, like right now, like exactly, like I have only my microservices and my mail server, but I don't have like RabbitMQ. I use Service Bus. For my storage now is Cosmos, so I don't use Redis, and everything go through Evanov. And I didn't need to change any code again. Like when I went to Kubernetes, basically, if you check, let's say the entry cam here, I was using binding MQTT. But when I went to Azure, I just replaced that, hey, now I'm using Evanov. So that's the only thing I change. And maybe last thing, how simple it is to say to an application. So let's say today you have your microservices, but you don't use Dapr, but tomorrow is like, oh, I think I will start leveraging Dapr. The only thing you need to do after installing Dapr in your Kubernetes cluster is to pass those annotation. And this is the one that important is like, hey, now this is like a Dapr application. So kind of Daprize my application. And you're good to go after that. Your application is now a Dapr app. So I put some resource. I know that Naveed share the PowerPoint. So here, like, if you're more interested, they have like an official YouTube channel, and they have like even the Dapr Conf. I think they got like last year was the second year of that. So a lot of people like talking customer, or they use Dapr, and some even like run on premise. So it's pretty interesting. Like I said, the Dapr workshop. So the app that I show, it's part of the Dapr workshop. So if you want to learn more Dapr deep dive, and Microsoft wrote like a document, like a free PDF book that you can download that is Dapr for a .NET developer. I don't know if we have any more question in the chat, Naveed, or?
I don't see any questions.
Okay.
Please, if I know we are a little bit over, if you have any questions, please feel free to, unmute and ask. Okay. Thank you.
So
Thank you. Let me go ahead, please.
one question is, let's say when we have Dapr installed on our Kubernetes and there is an upgrade we are planning for, right? So whenever we do the upgrade, let's say 1.8 to 1.9, what I have seen is I have to restart all my workload. Let's say some API is running, which is there, the sidecars are injected already.
Mhm.
If I'm deploying new version, I have to restart everything, which is a cause of downtime in that particular, or all the API which are using that Dapr. So how to overcome that situation?
Yeah, that's a good question. To be honest, I will need to check. So feel free to reach me on LinkedIn. I will take a look at that. Yeah.
Okay. Okay.
Any other questions, folks? Thank you, and hope to see everybody next week. Give me 1 minute to stop the recording.